thank you. Well, hi all, I guess I will be speaking in English, so it's not my first language, so sorry for any mistakes that I will make. Okay, I will talk about microservices architecture, how it's influence, how it has influence on the teams, how we reorganized ourselves thanks to this architecture, and talk about a little about the mistakes that we have made, but I will not talk about the architecture itself. This is generally another topic, not for the 40 minutes. But first of all, I will talk about the company, but I'm not a marketing guy, so it will be very, very short. So I'm from Comarch. It's a company which has headquarters here in Krakow, 5 minutes from here, which is very nice because I haven't got stuck in traffic today, which is very common in Krakow. So basically, we do a lot of businesses, and I won't talk about all of them. I will talk about one particular business. I'm from the telecommunications sector, and I'm working on operation support system. And this system generally is made for telecommunication companies, major telecommunication companies, which deliver services for phone users like internet, voice access, and so on. And we help them build their networks so they provide services without any stops and with good quality. So I want to talk about this just to get you familiar with the complexity of the business we have to deal with. So basically on the left you can see things that can be configured using our system. So our system configures transceiver stations, any devices that allow to communicate with these stations, with these towers, and generally our tool is to allow the telecommunication businesses to grow the network, to provide better services with better quality. Okay, so 2 cases that I will talk about. One case is when 2 big companies in Germany merged, and they created one huge company, and they didn't want to have so much these transceiver stations, and they asked us, "Dear Comarch, could you help us to make these transceiver stations a little less, because we have to pay for them? It's really this isn't usually these telecommunication companies don't own these transceiver stations. They rent them and they power them, so it's a huge cost, and they want to reduce it. And they wanted to figure out how to reduce it. So we came up with an algorithm. We took topological data from maps, population data. So we migrated to this system data about these transceiver stations, about their strength, signal, angles, and everything like that. So, and we counted up this, we pointed out the transceivers that can be removed from the planet. And it was a quite nice success, and we are very proud of it. And the second case, we are doing a project in Brazil, and well, generally in South Africa, in South America, several countries. It's a project that we design optical fiber network among the whole country, huge countries, and just to have, we're just not dealing with the basic data. We have a data that are in many, many states. Here you have some of the states of data. We have the current data on this data. So on this current network, we plan things. This is a new perspective. The things that we plan, then they try to introduce to the network. We communicate with the machines on the network, get the data back. This is a new perspective. We compare this data to the plan. We show them where you have mistaken. And then we have new perspective to repair those mistakes. So each data in our system have many, many levels on which the data can be and can be planned on the network, in the system, and it really is doubles or triples the complexity. Okay, so about the architecture. I won't talk about much about this, but this is a pretty standard setup for the microservices, I guess. So we have a interface. Usually we have a user interface that is detached from the core microservices, and each microservice can have many instances of the same microservice, and up on top of this we have orchestration tools, security tools, load balancing tools, configuration, and of course we have southbound interfaces and databases and all of the data source. Pretty basic setup, I guess. I guess most microservice architecture systems can apply to that. Yeah, but this is for the marketing, and this is how it really looks like. Less colors. So we have our user interfaces communicate with AG proxy, which does the load balancing. We have service discovery, currently Zookeeper, Keycloak for authentication, and the core services which do a lot of communication using REST, right? So pretty common. But long time ago, this was not the case. We've moved to this architecture, but it really wasn't very easy. And before microservices, our teams were slightly different organized. So also, I wouldn't say that we had a monolith system, but in some part, yeah, it was a monolith with some services around them. This was kind of a service-oriented architecture, but not the microservice. The basic difference is that we could not replicate. We had this wasn't domain-driven design that each microservice had its own domain. No, there was quite more like monolith, and it really affected how the teams look like. So the teams look like that. We had product teams. We have product with team leaders and developers in this product team, and around that team were floating a lot of other people who influenced that team, or the team should communicate with. And we gathered this communication into a process. We call that production process. In every company, there's a production process. Sometimes it's more defined, sometimes it's less defined, but production process always exists in the company. It's sometimes, and based on that production process, produces the architecture according to Conways Law. Are you familiar with Conways Law? Anybody heard of it? Yeah, some few people. Great. So it really works, and this is the proof that it works. This wasn't very good organization, because if I draw the lines show the production process communication. So the communication that needed to be done to produce something. And this communication and orchestration of these teams were formal to some point. So every arrow means that every team and means every communication that had to be done, and every arrow that's a task in Jira, or a stage, or a document, or sometimes a talk, or a click of a button in Jira just to move an epic to a new state, or a story to a new state, or something like that. Yeah. So in our company, it was well defined, I must say, this production process, but it really took time. So to deliver something for each hour, even if these people talk a lot, and this collaboration is very good, it takes time. Every production process takes time. So the goal is to reduce the lines and make them vanish. And you have two ways to make these lines vanish. You can either broaden the teams or define communication in such a way that it doesn't block the process. So either it's very fine defined communication and team knows what needs to be delivered, doesn't need no acknowledgement or acceptance in those teams. Okay, so how did it work? I'll start with the product owners. These product owners, our whole product was divided into modules, and each module was assigned a product owner. And this product owner said that we should do this or that way, and this should be done, or this shouldn't be done, or we have to have this in the product, or we shouldn't have this in the product. And what the requirements for the product came from the projects. So first of all, we tried to have the product. It's really a very, very hard case. If you just deliver something for one customer, it's really easy. If you try to have a product and deliver the same product among several customers, it's really, really hard. So especially when it's not Windows, which basically everybody can use and nobody can really say, I don't want this icon to look like that, please change it, Microsoft. No. We go to the customer and the customer says, I've paid for this solution, I can make you to this solution, you make this solution the way we want it. So it's really hard to say to the customer, you won't receive what you want. We will do it our way, and it's the only way. Yeah, sure, we can negotiate, but we want to give you a product. And the other customer and other two customers said it should look like that. And our analysts say it should look like that. But for the project analysts, when they're assigned to the project and they work with a single client directly, it's really hard for them to say that, dear customer, you won't receive it, because they are on site, they talk on a daily basis with the customer. They don't have the tools to say to the customer, I cannot deliver it to you. So it was very hard at that moment to produce a product. And also, tests and quality and assurance and quality assurance engineers were away from the teams in a separate department, and they provided end-to-end tests of our system, of our solution, and reported bugs and always mumble that our solution is lower quality and this and that. But you must know that, sure, nobody says anything about it. I watched several presentations, but I want to stress out each of these arrows gives stress to the organization. When project goes wrong, when something wrong happens, each of these arrows is an argument. Each of the arrows generates conflicts in the organization, which is not good. So I think not only as removing those arrows as making something faster, people work better without the arrows, right? And also problem solving with this when the situation is bad. It's really a good image of this. What happens? Teams, testers say it wasn't our fault. They give it to somebody else and push the problem away. They try not to handle the problem. They just give it away. And the Conways Law. So the organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And this really applies. But I cannot really tell you what was first, the chicken or the egg, because I don't know if whether we changed the organization first or we've changed architecture first. It kind of moved along. We changed the organization and we changed the architecture at the same time, I must say. And what was our goal? Well, the goal was to go as fast as possible, to deliver good quality, fast, without hesitation. So time to market should be as fast as possible. Also, what is important, we want to have a product, right? So we don't want to satisfy every customer in every way, because we tried to do that. And it's impossible if you want to have a product. It is not possible to satisfy every customer. So we thought that maybe we'll organize product-based structures. And, you know, this is a strong matrix in most companies that deliver solutions to the single client, and this is a single solution, not a product. It's just a system that has to work from one single client. It usually looks like that. You choose developers, quality assurance, analysts, project manager, and provide a team, go fight, deliver, agile and scrum, and yeah, all the buzzwords, and it's delivered. It's all fine. But when you have a product, it's more of a problem. Because if you choose some developers, some analysts, and go to the one client, and choose another analyst, go to another client, and they will have to analyze the same thing. So, for example, planning of radio stations. So these two analysts will design it in other way, although they should make it the same. It's very simplifying that, of course, but it's the case. So we cannot build teams around projects. So we have to build teams around products. And product is not another dimension. Product is the dimension and project isn't. So we've built it around the product, and we have the product team right now. So this is our current setup. We moved quality assurance to the product team, analytics to the product team. With head of the product team is the product owner. Team leader is responsible for development and for the quality. Therefore, he's responsible for the quality. So he organizes the work of quality assurance, of course. We've left user interface out, and in a few slides I will tell you why. We've added architects. Architects are really important in microservice architecture, because microservice architecture is difficult, and I will tell you why in a moment. And the only thing that is in the project is the project manager. So yeah, of course, that's usually not a one person. There's stream leaders. Also, there's teams like my data migration interfaces, all the things that needs to be done, especially for the projects. But this is not the part of the product. Okay, we keep it away from the product. So the project manager communicates with product owner. Product owner delivers analysis, and if analysis is in this one team, it always will be product analysis. Those analysts won't do something not according to the product, because they want to deliver product solutions. So making things packed up in one thing, in one place, reduces the communication. And what is more important for me as a department manager, it reduces conflicts. Now they are working as a one team. Analysts won't say that, oh, those developers always make crappy software and this and that, and the testers cannot test. No, they help each other now. So it's really important to to have a focus of this group of people on one task to deliver product in good quality. Okay, why there is no arrow between teams and operations? It's because we thought that the teams should deliver a standard, scalable, stateless deployment package. And for really, the operations shouldn't know much about the business, because in our case, the business is very, very complicated. We don't want to teach operations about the microwaves, about radio transmissions, and everything like that. So each team should deliver a package. This package should be a standard package. This is very important. I'm not talking about any particular solution like a Java Enterprise Edition, or that it should be a Spring package or a Docker package. Doesn't matter. This should be standardized in our case, so that the operations take this package and put it on the environment, and this package works, right? They don't have to know what this package really does, and it should be scalable. It's very important because about this requirement, the developers usually forget. And what does it mean that it's scalable? It means that it can have multiple nodes of the same time, at the same time. Nodes that, for example, write to the same database, right? So problems with caching, right? So there are very many problems that has to be covered by saying that this microservice should be scalable. Also, this microservice should be stateless. It's also important that the operations shouldn't think about whether they can shut down this microservice and put it up again, if it will break any sessions or not. They should be 100% sure that it won't break any sessions. That's why it should be stateless. And what should operations deliver? Problems to the teams. Operations should always deliver problems. You know, for example, your microservice uses too much memory. For example, your microservice responds in a very long time, or your microservice fires 1,000 REST operations in a second, or something like that. Also, static code analysis. When operations take a package and try to put that package on the environment, they should at least check. And I'm not saying that they should test it. They should check it, the outcome of the tests. If the unit tests are passed, if the testers say that all the new requirements are passed, static code analysis. Yeah, operations should check it, whether the static code analysis is on appropriate levels, and they should report problems. These operations should always report problems to the teams. User interface. Why we've moved our user interface away from the teams? It's because the majority of our business is our business logic. So we do our stuff on the server side, away from the user. User just makes 2 clicks sometimes, and there's a huge amount of count up and logic behind it. So our user interface is usually simple. Some tables, some graphical, sometimes presentation of data, but it really is simple to comparing to the business logic behind it. So we've moved away because sometimes even our system only has no user interface. It just sits in the background and orchestrates other systems on the client's environment. So we came up with this, that not every team should have JavaScript developers or front-end developers. We moved them to one team, and they provide kind of a framework for to which other teams use. And why there's no arrow between that is that to deliver something, our product teams don't communicate with this team, with this UI team. UI team presents a contract. If you want to show data in this and this way, you should fill the contract in this way. Okay, it's just something that in this contract, also beside the definition of the layout, for example, that there should be a table and there should be list. There's also a behavior. If you click on that, something must be selected or something must be counted. And this is a contract for the developers, for the product developers, Java developers, that they should fill. They fill this contract and they don't have to care about how it looks. Because if they want to change the looks, the UI changes the looks. But they change the looks for the whole product. Also, the user interface doesn't know anything about the logic. There isn't any logical structures, any logical functions, any checking if the data is right or wrong. Right? And microservices are really difficult. And I'm passionate about microservices and Java, and generally a Java developer. And for me, microservices are really difficult. And for most of people, usually the microservices are difficult. And it's really easy to come up with a service that is cloud ready, and you put that service into a cloud, and they have all this free cloud services. You can write something in 5 minutes, poof, Shazam, and it's on the internet, and you can write REST queries and do this and that. But the problem is that when you have a large system and many microservices that cover a large area of the system, comparing to the monolith, you have problems. You have several problems with this system. For example, there is no data consistency. And I think this is the biggest problem here. In true microservices architecture, there are no distributed transactions, right? So, for example, if you give one microservice data, and it has its own transaction inside. Inside the microservice, data is consistent. That is obvious. But if you give data to one microservice, and then you add an event on the queue, and another microservice consumes it, and it breaks down. You have data consistency. You have to think about that. You have this data correction actions you have to make in your code, and you have to think about everything that, for example, you can have caches, because one microservice can update this cache, another then will have another old copy of the data, and you have to think about all of the things. And also, when in monolith systems, database tells you when the data is not consistent, right? You have foreign keys and all this stuff, and now you don't. So, but still you reference to this data by ID or anything like that, right? So microservices are difficult in that way, and there's a huge communication overhead on the microservices architecture. You have to think about that. All the queues, all the REST communication. Yeah, it's fun and easy when you deliver very small system, and we have large systems, large amount of data, right? The data from the base stations is really, really huge. There are gigabytes and gigabytes of data daily. So it takes much more effort to deliver microservices. So that now you have to think about all that. When you have to deliver a single thing, you have to think about a lot of. You have to make a lot of effort to communicate with other services. To, for example, single sign-on, tokens, logging. So when the user request comes to your system, and there's a huge amount of hops in the microservices architecture, right? And how do you know that this particular microservice broke down because of this request? Sure, we have tools for that. We can add tags to the REST requests, REST queries, and it will be propagated. But you have to think about that. You have to think a lot of more things. So it's really easy also to over-engineer. When we came up to the idea, it was like that. We thought about the renewal of our architecture. We came up with REST communication, tried to read something about it. Martin Fowler Yeah, we read about it, and we listen to to Adam Bean, of course, and we took our lessons, right? But then we thought, yeah, this is a great idea for our complex system. Let's microservice all the things. And we start to implement a lot of microservices and came up with a lot of ideas, and it was really, really bad. Microservices shouldn't be that fine-grained. The microservice should focus on one domain, right? If you speak with the same language about something, they should be on the one microservice, right? Don't spread out much. Also, I found out, I was thinking about it, from what point we have any income from the microservices. And I think that organizations starting with 30 developers, that is mine boundary, that should use microservices. Till 30 developers, I would go with a monolith architecture that can be reproduced several times. Why am I talking about developers and not about the system, the complexity, the case? Well, it's crucial, because really, microservices architecture doesn't give so much benefits to the system itself. It does benefits the team's organization and not the system itself. Usually, we can have a monolith systems replicated several times that is scalable. It will be fine. It will work faster than microservices, really. But if we have a huge monolith, these teams cannot handle it. They will fight about it. Teams and developers like to have a single microservice, and they like to work on this microservice, and means that there's their child, and their child works perfectly, not the whole system. You know, they cannot handle the whole system. They cannot handle the whole monolith. And the worst thing is that when the monolith builds together, that's the worst case. Architects, yeah. So the architects are the most experienced developers. We have a team of architects. And it doesn't go this way that they go to the teams and say, oh, you do this wrong and do this way, and they go away. No, that doesn't work that way. This kind of architects I would call Teflon architects, because nothing sticks to them. They just talk rubbish and walk away and nothing sticks. No, if you're an architect, you go to the team, you tell them, how would you do that? But before you tell them how would you do that, you first learn about the team. Learn about the problems, learn about the business. You come up with a solution, you join that team, and you make that solution happen. You prove that your solution was right. So you stay in that team for 3-6 months, right? Till you prove that it is good. So the architects are really like commandos, right? You know, they stand in sheet for the neck and they don't hesitate to kneel, right? So they are really tough guys that tell this should be done this and that way, not another, and they prove it right. And also teams versus teams. There shouldn't be any hard dependencies. So seriously, what is a hard dependency? If you have a library, for example, jar file, and you add that jar file to another team and they use it, that's the hard dependency. And there shouldn't be any. I mean, seriously, we don't want to have even hard dependencies to third-party libraries, to open source libraries, because it's usually wrong. Usually you don't need it. You provide a REST service, access this REST service. Your system, if the other team does something wrong, it breaks up, your system should work. At least it should compile. Okay, healthy competition. It's really hard to get a healthy competition between the teams. Usually the teams that The worst case is when two teams are in different locations, right, in different cities, and they usually say, oh, this from this city, they are always making this system bad, and they cannot code and something and blah, blah. And this is really hard for the managers to handle it, but we have to, right? So we should introduce healthy competition. So if one team comes up with something good, they should share. Also, switching between teams. It's really good that when teams help each other. Like, for example, code reviews. We do cross-team code reviews, which is really great. People learn from it a lot. And also, from time to time, and this is quite often, we take developers and switch teams. Yeah? So they try to understand, because these microservices always talk with each other. So they should talk. When they switch teams, they cannot blame the team from which they came from, right? And this team versus team communication shouldn't be defined by a process, in my opinion. So let the developers do the talks, let them work, let them make great systems. Here's what it looks like now. So we have teams organized in product lines. In each product line, we have several teams. Each team is responsible for handling few microservices. These microservices are always from the one domain. They always talk using the same language and handle the same things, so they don't spread out. And it's really, the developers are really happier like right now. I can see from their faces. Usually when the developers work in huge monolith systems, they are depressed, really. They cannot handle the whole system. They cannot easily test it, easily build it, easily run it. They don't go fast enough. They are blocked by several things. For example, other team messed up with the build, other team messed up with the system, so the system won't start up. And system startups in 10 minutes, for example, that's too long. When they have their own microservice, which they can run on their machine, build on their machine, test it on their machine, mock, make something, fire, and then check in 2 minutes if it works or not, then they are happy. And this is our goal. Okay, that's all what I have to say for today. If you have any questions, please. Thank you.